Hey guys, so today we're going to be doing a problem from Energizing Physics 2.6. The question says, Packy throws a 0.75 kilogram ball straight up out of the window shown in this drawing right here. A asks to determine height 2. B asks to determine V3 with the ground as height equals 0. And C asks to determine V3 with height 3 at 0. So first we're going to be doing part A, which asks to find height 2. And we start this off with saying that E1, or energy 1, is equal to energy 2, because we know that this system, in the system, energy is conserved, so the energy at each point is equal to the energy in each of the other points. So at E1, we know that there's height, so there is GPE, and there is a velocity, so there is KE. But at point 2, there is no velocity, so there is only GPE. And from these equations, we know that GPE1 is equal to mgh1, and KE1 is equal to 1/2 mv1 squared equal to mgh2. And from this, we plug in all the, from this we see that there's m in each of these values, so we can just cancel that out and then plug in the values that we know. G is equal to 10, height 1 is equal to 5 meters, V1 is equal to 8, we square it, and then G is equal to 10, and then H2 is unknown. When we do all the math out, we get 50 plus 32 is equal to 10H2. And I'm using it. And then from this we can determine that height 2 is equal to 8.2 meters. Moving on to part B, we can determine V3 starting with the same method, knowing that the energy at point 1 is equal to the energy at point 3, and at point 1 we already know there is GPE, because there's height, and KE, because there's velocity, and at E3 there is height also, because we are setting the ground as 0, and V3 there is also a velocity. Plugging in what we know from these equations, mgh1 plus 1/2 mv1 squared equals mgh3 plus 1/2 mv squared, 3 squared. And then, same as in part A, m, or the mass, is a common variable in all of these, so we can cancel it out. And then plug in what we know. 10, 5 plus 1/2, 8 squared equals 10, 3.2 plus 1/2 V3 squared. And then if you do all the math out, 50 plus 32 equals 32 plus 1/2 V. And when you square this, you get that V3 is equal to 10 meters per second. Oh, square root this, sorry. And then in part C, we have to do the same process, except one difference is that instead of setting the ground to 0, we set height 3 equal to 0. So we can set this up the same way. E1 is equal to E3, except now in E1 there is still GPE1 and KE1, but in K3 now there is no GPE because this is set as 0. So there is only KE3. And we can plug in what we know. And the difference here for height 1, we know from before it is 5 meters, but now we are subtracting the height 3 from height 1 because this is now set as 0. So you have to do 5 minus 3.2 because that is height 1 minus height 3. And then you plug in the other variables as normal. And then you get that this is 10 times 1.8 plus 1 over 64 equals 1/2. And then when you add this all up and multiply it out, you get that V3 is equal to 10 meters per second, the same answer that we got in part B. Part D now asks that it says, you should have found that your answer to B and C are identical. Why doesn't the velocity at point 3 depend on the reference height? So we found that these two velocities are equal, and the reason why the reference height in each of these points don't matter when calculating the velocity is because it is the change in height that matters, in displacement in energy. So the change in GPE is what affects what velocity 3 will be, not the height specifically that we start off on. And for E, we can see that all of the values that we are given have 2 sig figs, so all of our answers also have 2 significant